The issue with existing batteries is that they're expensive, they're unreliable, they're sort of stinky, ugly.
Tesla CEO Elon Musk is shaking up the EV world once more. But could this be the biggest disruption yet? Musk claims Tesla's new aluminum-ion battery can fully charge a car in just 5 minutes. But is that really possible? Could this breakthrough make EVs faster, cheaper, and safer than ever before? And if it works, how will it reshape Tesla's future and the entire automotive industry? The big question remains. Is this the moment Tesla finally leaves lithium behind and changes the rules of electric vehicles forever? So why is Elon Musk and Tesla even looking beyond lithium? For years, lithium has been the backbone of electric vehicles, powering everything from Tesla's Model S to the new Cybertruck. But here's the catch. Lithium isn't perfect. First off, it's expensive. Prices have been skyrocketing as EV demand grows. Mining it isn't easy either. Most of the world's lithium comes from just a handful of countries like China, Australia, and Chile. That makes the supply chain fragile. A political hiccup, trade issue, or natural disaster in one of these regions can spike costs and slow down production. And it's not just the price. Lithium mining can be brutal on the environment. Water consumption, land disruption, even ethical concerns around cobalt used in some lithium batteries, all of this adds up. For a company like Tesla, which wants to make EVs faster, cheaper, and accessible to millions, relying on a rare, expensive, and sometimes problematic resource creates real challenges. Elon Musk has been talking about this problem for years. He's warned the industry that if an alternative isn't found, electric cars could stay expensive, and the dream of a mass EV market could stall. Competitors like BYD, Volkswagen, and Toyota are still heavily tied to lithium, which leaves them vulnerable if prices continue to rise or supplies tighten. Tesla, on the other hand, has been quietly betting on the next big thing, a battery that doesn't just rely on lithium. Here's where it gets interesting. Tesla's new aluminum-ion battery isn't just about speed. It's about solving these lithium problems. Aluminum is cheap, abundant, and found almost everywhere, unlike lithium, which is concentrated in a few countries. It's also lighter and more stable, which could make batteries safer while giving EVs better performance. But the real kicker? According to Musk, it could charge a Tesla in just 5 minutes. That's not hype. If it works at scale, this isn't just a small improvement. This could shift the entire EV market, make cars cheaper, and put Tesla far ahead of everyone else still tied to lithium. And while lithium will still exist, its monopoly as the king of EV batteries could be seriously threatened. So the question now is, how exactly does this aluminum-ion battery pull off such insane charging speeds while staying safe and reliable? That's where Tesla's secret tech comes in, and it's what we'll dive into next. Elon Musk isn't just talking about faster charging. He's talking about a completely new chemistry that could rewrite the rules of EV batteries. Meet aluminum-ion technology. Unlike lithium, which moves a single ion at a time, aluminum ions can carry 3 charges at once. That means more energy transfer in a smaller, lighter package. Tesla's engineers are exploring this not just for speed, but for durability and safety too. So why does this matter right now? For drivers, it could mean a Tesla that charges faster than your morning coffee break, while also lasting far longer than today's batteries. For Tesla, it's a way to reduce costs, bypass supply chain headaches, and stay ahead of competitors still relying on lithium. Analysts are already buzzing. Aluminum is abundant, inexpensive, and far less volatile than lithium. That stability isn't just convenient, and it's a huge safety advantage. The tech behind Tesla's new aluminum-ion battery is nothing short of fascinating, and CEO Elon Musk has just dropped a bombshell that could redefine electric vehicles forever. Imagine a battery that charges a car in just 5 minutes. Yes, 5 minutes, and yet can handle thousands of charge cycles without losing its punch. At the heart of this innovation is clever chemistry and engineering. Graphene forms the cathode, aluminum foil the anode, and a specially designed ionic liquid electrolyte makes the system incredibly efficient. Early prototypes have shown they can absorb massive amounts of power in record time without overheating, something lithium-ion batteries struggle with. But why does this matter? Why should anyone care about a 5-minute charge? The answer is simple: convenience, reliability, and affordability. If Tesla can make this technology work at scale, it could fundamentally change the way we drive, charge, and think about electric cars. In practical terms, this could mean that a quick coffee break or pit stop feels almost identical to filling a gas tank. No more waiting half an hour or more at a charging station. No more range anxiety constantly in the back of your mind. And for everyday EV owners, this isn't just a luxury. It's a game-changing convenience that makes electric cars genuinely competitive with gasoline vehicles. Experts are watching closely because this isn't just about Tesla selling more cars. It's about shifting the entire landscape of energy storage, mobility, and infrastructure. Competitors like BYD, Volkswagen, and even emerging startups are racing to develop similar technologies. But Tesla has a clear edge: experience, scale, and Elon Musk's relentless drive to innovate. Musk isn't making casual promises here. A 5-minute charge isn't a marketing stunt, it's a statement. He's telling the world that Tesla is not just thinking about batteries. Tesla is redefining what's possible in EV technology. But the big question remains: how quickly can these batteries actually be rolled out for real-world cars? And more importantly, will they deliver the same reliability and safety that Tesla drivers expect? Here's where science gets fascinating. Aluminum ions carry 3 electrons each, which is triple the amount that lithium carries. This allows far more energy to flow through the battery in a much shorter time. Combine that with a graphene-based cathode, a flexible and efficient ionic liquid electrolyte, and you've got a system that can handle ultra-fast charging without overheating or causing dangerous thermal events. Lithium-ion batteries often run into problems when you push them this hard. Fires, capacity loss, and dendrite formation are common. Aluminum-ion batteries, on the other hand, are more stable and safer. But how does this translate to everyday driving? Imagine charging your car from 0 to full while you grab a coffee, finish a quick meeting, or even walk your dog. Tesla is hinting at a reality where the electric vehicle experience is faster, safer, and more reliable than filling up a conventional car. Think about the broader implications for the average Tesla owner. If a Model 3 or Model Y could fully charge in under 5 minutes, this opens a world of possibilities. Long road trips become practical again. Commuters wouldn't need to plan their lives around charging stations. Urban EV fleets could rotate vehicles more efficiently, reducing downtime and increasing productivity. And because aluminum is more abundant and cheaper than lithium, Tesla could potentially reduce production costs, passing savings on to buyers. Could this finally make electric cars more accessible to the mass market? That's exactly the question Musk is pushing everyone to consider. But what about durability? Unlike lithium-ion batteries, aluminum-ion batteries can endure thousands more charge cycles without significant degradation. This isn't just about charging speed. It's about making EVs that last longer and maintain their performance over years of daily use. Experts point out that combining aluminum's trivalent charge with the flexible electrolyte is key. It allows Tesla to push enormous amounts of energy into the battery safely and consistently. And because aluminum is less reactive than lithium, the system is inherently safer. No risk of spontaneous fires, no need for heavy safety add-ons, and far fewer environmental concerns compared to lithium mining. So, could this be the battery that finally makes EVs safer, cheaper, and more reliable than gasoline cars? Tesla seems to think so, and Musk's public hints suggest he's ready to prove it. Of course, scaling this technology is a huge challenge. Lab tests are one thing. Building millions of batteries for a global fleet of vehicles is another. Tesla must perfect manufacturing processes, maintain rigorous quality standards, and ensure every battery performs safely under real-world conditions. Even small errors in production could affect efficiency, lifespan, or safety. This is why industry watchers are so intrigued. The technology works on paper and in prototypes, but turning it into a mass-produced solution is where Tesla's engineering prowess will be tested. What does this mean for Tesla's competition? Other manufacturers are experimenting with similar concepts, but none have the combined advantage of proven EV platforms, massive production capacity, and Elon Musk's vision. If Tesla can roll out aluminum-ion batteries successfully, it could leap years ahead of competitors, cementing its lead in the electric vehicle market. Imagine a world where Tesla cars dominate, not just because of performance or software, but because the very core of their energy system, the battery, is faster, safer, and cheaper than anything else available. And the potential doesn't stop at cars. 5-minute charging aluminum-ion batteries could revolutionize energy storage for homes, businesses, and even cities. Tesla's superchargers could become smarter and faster, allowing more vehicles to charge simultaneously without upgrading power lines. Tesla Powerwalls could store energy more efficiently, reducing reliance on the grid and integrating solar energy seamlessly. Even large-scale industrial energy storage could be transformed, helping stabilize grids and make renewable energy more viable. In other words, this isn't just about EVs. It's about reshaping how energy itself is stored and used. So, the big question remains: is this the future of electric vehicles? Tesla's aluminum-ion battery promises speed, durability, safety, and sustainability, but the real test will be scaling this for everyday drivers. Will we really see a car that charges in 5 minutes parked outside your local coffee shop next year? Or will production challenges slow the rollout? Elon Musk's track record suggests he's willing to tackle massive engineering challenges head-on. And if he succeeds, it could redefine what we think is possible for transportation and energy. Ultimately, aluminum-ion technology could put Tesla years ahead in the EV race. Faster charging, safer chemistry, lower costs, and longer lifespan. It's a rare combination, but Musk isn't stopping at cars. He's hinting at an entire ecosystem of energy solutions powered by these batteries. From superchargers to home storage and even city grids, this could be the start of a revolution in how we use, store, and think about electricity. And the most exciting question of all is, when will it hit the roads, and how quickly will it change the way we live? So, the 5-minute charge isn't just about speed, it's a window into a future where EVs are seamlessly integrated into daily life. Next, we'll dive into how this new aluminum-ion battery stacks up against lithium-ion, and why it could leave conventional batteries in the dust. Elon Musk isn't just promising speed with Tesla's new aluminum-ion battery. He's also tackling durability, safety, and sustainability head-on. Unlike traditional lithium-ion batteries, which can overheat, swell, or even catch fire under stress, aluminum-ion batteries are naturally more stable. Aluminum doesn't react violently, and combined with Tesla's carefully designed ionic liquid electrolyte, the system can handle extreme charge and discharge cycles without risking a meltdown. Why does this matter? For EV owners, it means fewer worries about battery degradation over time. Lithium batteries typically lose capacity after a few thousand cycles, but aluminum-ion technology could last 3 times longer, keeping your Tesla performing at peak levels for far more miles. That's not just good for drivers, it's good for resale values and long-term costs too. Sustainability is another key piece. Aluminum is abundant, recyclable, and far less environmentally damaging to mine than lithium or cobalt. Tesla could dramatically reduce its reliance on rare and controversial materials while still delivering high performance. Experts are already noting that this could reshape how the industry sources battery materials, making EVs cleaner from production to disposal. Even Tesla's competitors are paying attention. While other companies race to develop faster lithium-ion batteries, Musk's aluminum-ion approach sidesteps the usual trade-offs between speed, lifespan, and safety. It's a balancing act that few have achieved at scale, and Tesla's roadmap suggests they're ready to prove it in real-world conditions. But the most exciting part? This isn't just about electric cars. The same battery design could power homes, offices, and even the grid more efficiently, offering high-density energy storage that's safe, long-lasting, and eco-friendly. It hints at a future where energy storage is no longer a bottleneck for renewable energy adoption. Next, we'll take a closer look at how Tesla plans to integrate this battery into its cars and supercharger network, and why Musk's vision could redefine the way we think about electric mobility entirely. Before we dive deeper into Musk's aluminum-ion breakthrough, it's important to understand what Tesla has been doing so far. Tesla's current vehicles rely heavily on lithium-ion batteries, including the latest 4680 cells, which already marked a major step forward in energy density, efficiency, and cost reduction. These batteries help Tesla achieve longer ranges, faster charging than older models, and a more sustainable manufacturing process. But even with these advances, lithium-ion has limits. Charge times still hover around 30 to 60 minutes for fast charging. Thermal stability can be an issue, and production depends on scarce materials like cobalt and high-purity lithium. Tesla has been pushing the envelope with improvements, like structural battery packs and improved cathode chemistry. Yet the company's engineers know there's a ceiling to what lithium-ion can deliver. This is where Musk's announcement of a 5-minute charging aluminum-ion battery really shakes things up. By comparing the two, we see a potential leap not just in speed, but in safety, lifespan, and environmental impact. Industry experts are already speculating how this could shift Tesla from being a leader in incremental improvements to the first automaker with a truly next-generation battery. For EV owners and enthusiasts, the difference isn't just technical, it's practical. Faster charging, more durable cells, and cheaper, more abundant materials could reshape everything from road trips to resale value, and even how utilities integrate EVs into the grid. But here's the question everyone's asking. How will Tesla actually transition from lithium-ion to aluminum-ion at scale? And what does that mean for the next generation of vehicles? That's exactly what we'll explore next as we look at the practical rollout and performance potential of this new battery. Elon Musk's revelation of a 5-minute charging aluminum-ion battery isn't just a win for Tesla drivers, it could shake the entire global supply chain. Right now, the EV industry is heavily tied to lithium, cobalt, and rare earth materials. Mining, refining, and shipping these materials is expensive, environmentally taxing, and often geopolitically sensitive. If Tesla successfully scales aluminum-ion batteries, the reliance on these materials could drop dramatically. Aluminum is abundant, cheaper, and easier to recycle. That alone could reduce costs for Tesla and other automakers while making supply chains more resilient. Experts are already speculating that mining operations focused on lithium and cobalt could see a slowdown, while aluminum production and recycling sectors might experience a sudden surge in demand. Competitors aren't sitting still either. Legacy automakers and battery manufacturers will have to rethink sourcing strategies, manufacturing processes, and R&D investments. Partnerships, raw material contracts, and even international trade policies could shift as everyone tries to adapt to a world where aluminum takes center stage. For consumers, the impact could be huge. More affordable EVs, faster production timelines, and less strain on global resources mean the promise of mass adoption is closer than ever. But there's a catch. Scaling aluminum-ion technology from lab prototypes to millions of cars is a monumental task. Production challenges, supply bottlenecks, and regulatory hurdles are still ahead. So the big question remains, can Tesla not only innovate in the lab, but also master the global logistics to make aluminum-ion the new standard? That's exactly what we'll explore next when we dive into what Musk and Tesla have planned for real-world implementation. When Elon Musk announced Tesla's aluminum-ion battery with a 5-minute charging promise, it sent shockwaves across the automotive world. Competitors are now facing a dilemma: innovate fast or risk falling behind. Traditional automakers who have invested billions in lithium-ion technology suddenly have to rethink their strategies. Some are already accelerating research into alternative chemistries, while others are exploring partnerships with startups to catch up. Battery suppliers and tech companies are watching Tesla closely. A breakthrough like this doesn't just affect Tesla cars, it could redefine standards for EV charging, energy storage, and even electric grids. Experts suggest that if aluminum-ion tech proves scalable, it might force the entire industry to pivot away from lithium, making previous investments less valuable. But there's also skepticism. Rivals point out the challenges of mass production, cost, and real-world reliability. Can Tesla deliver consistent performance in millions of vehicles? Will infrastructure, like charging stations, adapt quickly enough? Analysts are split, yet one thing is clear. The announcement has triggered a new arms race in battery innovation. For the EV market, this isn't just about speed, It's about who can dominate the next generation of technology. Automakers, investors, and even governments are reassessing priorities, and strategies are shifting faster than ever. So the question remains, can Tesla not only maintain its lead, but also keep competitors scrambling as aluminum-ion moves from concept to reality? Next, we'll dive into what this means for the future of EVs and energy storage on a global scale. Elon Musk's announcement of a 5-minute charging aluminum-ion battery is thrilling, but the road from the lab to the highway is anything but simple. Scaling this technology for millions of Tesla vehicles involves massive manufacturing upgrades. Aluminum-ion cells require precise engineering, new materials, and fresh production lines, none of which happen overnight. Then there's battery integration. Existing Tesla models are designed around lithium-ion chemistry. Swapping in aluminum-ion isn't just a plug-and-play situation. It may need re-engineered power management systems, cooling solutions, and even adjustments to car software. Even a tiny flaw could affect performance, lifespan, or safety. Experts also warn about real-world conditions. How will these batteries perform in extreme heat or freezing temperatures? Can fast charging repeatedly day after day degrade them faster than expected? Supply chains also face pressure. Sourcing high-purity aluminum, specialized graphene cathodes, and stable electrolytes at scale could be tricky. Finally, regulatory hurdles and safety testing take time. Governments won't allow a new battery to hit the streets until it passes rigorous standards, which could delay mass rollout. So, while Musk's aluminum-ion battery promises to redefine EVs, the next challenge isn't just innovation, it's execution. Can Tesla overcome these obstacles quickly enough to match the hype? Or will early adopters face delays and setbacks? In the next section, we'll explore what Tesla's roadmap looks like for bringing this technology to the roads and energy systems of the future. Elon Musk has once again pushed the boundaries with Tesla's new aluminum-ion battery, promising a full charge in just 5 minutes. But beyond the hype, this could signal a real turning point for the electric vehicle industry. Imagine a world where charging your car takes as little time as grabbing a coffee, where range anxiety becomes a thing of the past, and where EVs aren't just eco-friendly, they're faster, safer, and longer-lasting than ever before. For Tesla, aluminum-ion technology isn't just about cars. It could transform energy storage for homes, businesses, and the grid itself. Musk has long talked about a sustainable future, and this battery could be a key piece of that vision. Experts say competitors will have to scramble to catch up, and the entire supply chain, from raw aluminum to advanced graphene cathodes, will feel the ripple effect. Of course, challenges remain. Manufacturing at scale, regulatory approvals, and real-world performance under different conditions are all hurdles Tesla must clear. But if they succeed, we could see a shift in the EV landscape unlike anything before. Faster charging, higher energy density, and a more sustainable approach to energy storage. Ultimately, Elon Musk's aluminum-ion battery is more than a headline. It's a glimpse into the future of mobility and energy. Tesla is betting big, and the world is watching. Will this be the spark that ignites a new era for electric vehicles, or will the road ahead prove more complicated than expected? Either way, the aluminum-ion revolution has arrived, and it's only a matter of time before we see how far it can go.